We're continuing with section 4.7, example 2. Find two non-negative real numbers x and y such that their sum is 120 and their product is as large as possible. So this one we don't come up with any drawing, but let's say x and y, the variables already given to us, two of them, and so we know that x is bigger than 0 and y is bigger than equal to 0. It says non-negative, means 0 can be included. Other piece of information is the sum is given and the product is supposed to be as large as possible. So what is my goal function or objective function? It's to get the product to be as large as possible. That's the one that I'm optimizing. And so product P equal to x times y is the objective function. Then the other part is 120. 120 is the sum of x and y. That is the constraint. Now let's look at this. Objective function is function of x and y. I don't like that, so I have to use the constraint. That's the limit that I have for or bounds that I have and to solve for one of the variables. This time around, let's solve for y. And then put it back in the objective function. Replace, sorry. And that would be x times 120 minus x. Again, this is going to be quadratic, but we're not using our pre-calculus knowledge from now on. All the way to here, same thing as pre-calculus. From now on, instead of using the vertex of quadratic equation, we use one of the methods that we have. And so which first of all, derivative is always is going to happen. So let's take the derivative. And that is 120 minus 2x. And find the critical numbers by setting that equal to 0 in this case. And getting x equal to 60. And now let's do a test. Which test? First, domain. Domain is x bigger than equal to 0, and then maximum that it can get is 120. So domain is 0 and 120, closed bounded method, and I have to check p at 0, which is going to be, if I compute right here, I get 0. P at 120, again, if I compute right there, if I plug it in, I get 0. P at 60, which is going to be, if I plug in 60 into here, then I will get basically 60 times 60, which is 3,600, and this is the maximum product that I can get. That's a max value. And the question is asking find two non-negative real numbers, x and y. And so I found x over here, use the equation for y when we solved for y to find y. Y is going to be also 60. And these two are the answers. So we figured out how to solve example 2 when x and y were two non-negative number. What if I remove the two non-negative cause of the question? Then instead of x being bigger than equal to 0, and y being bigger than or equal to 0, you will have x to be any values that you want, and that x and y both are going to be any real numbers, and the other one can, when you add them up together, they have to be only 120. So that when I remove this, the domain becomes everything all the way to the domain is the same solution, but after that, domain becomes negative infinity and infinity. And then over here, I can't use the closed and bounded, closed interval method anymore. Cannot be used. And so what do? The best way is because you already have the derivative, the best way is to actually use the first derivative test. And so when you do the first derivative test, so derivative was p prime of x equal to 120 minus 2x. So first derivative test, f prime and 60, and before 60, you get a positive value. After 60, you get a negative value. Oh, look at this. Increasing before, decreasing after, and no other place that it goes up or down. So there is an actual maximum, max, at x equal to 60. And that's how you figured it out. So if the domain is different, you may have to use another method of testing. I click at question 2. Find two non-negative numbers whose product is 100 and whose sum is minimum. And please pause and come back. Okay, this is the opposite of the example that we did, or it's the other way around. If you look at this, what is the objective function whose sum is minimum? That means that, let's say, x and y are the two numbers. And what I know is x and y are both bigger than 0. Bigger than or equal to 0. It says that the objective is to maximize s equal to x plus y. The constraint is x times y equal to 100. So when I solve, then y is going to be 100 over x. Plug it back in. S is going to be x plus 100 over y, x. And then it would be x squared plus 100 divided by x. And then from here, I have to take the derivative. Look at this one. I like that one for the derivative much better than this one. So I'm going to take the derivative of that. And then over here, I get s prime of x. Common denominator, x squared minus 100 divided by x squared. So the critical numbers are going to be x equal to 10 and x equal to 0. X equal to 0 is not part of the domain, therefore, see, the domain is not there. Therefore, x equal to 10 is the critical number that I'm going to investigate. Here, I don't want to use the closed and bounded set because I just realized even though originally we assumed x and y can be 0, because their product is non-zero, they cannot be part of the domain. So let's draw the line integral, I'm sorry, line, number line, and put a 10 over here, and then evaluate. Anything bigger and smaller than 10, oh, sorry, we have plus, minus 10, and then anything between negative 10 and 10 is going to be negative. Anything over it's going to be positive. Anything, sorry, it's going to be negative. Anything above 10 is going to be positive. So here is what happens at 10. We have the minimum value for the sum, obviously, because that's the in the domain doesn't count. Is not include, and does not include negative 10. So domain is just x bigger than 0, and over x bigger than 0, we see that we have a minimum at 10. So x equal to 10, and then we solve for y, and y is going to be 10 also. So 10 and 10 are the answers. Here's another arithmetic question. The sum of two non-negative numbers is 16. What is the smallest possible value of the sum of their squares? So pause. Now, I compare question 3. The sum of two non-negative numbers is 16. What is the smallest possible value of the sum of their squares? Let's pause and then we come back. So if the sum of the two negative numbers is 16, that means, let's say x and y are the two numbers, and x plus y is equal to 16. Now, what is the objective? Objective is smallest possible, smallest, and sum of their squares. So objective is x squared, let's say SQ or Q equal to x squared plus y squared. Where was constraint? We just wrote the constraint. It's x plus y equal to 16. Since objective is a function of x and y, solve for y, for example, and get 16 minus x, and replace back in the objective function. And then, as usual, derivative. So q prime of x. So q prime of x equal to 2x plus 2 times 16 minus x, and derivative of inside, which is negative. This should be the negative 2 inside, and then you get 4x minus 32. That will give me Kirkle number x equal to 8. And then let's look at the domain. Domain, what's the minimum value for y I can get? Y equal to, for x I can get 0. And the maximum value is 16 because then y is bigger than or equal to 0 and adds up to 16. Therefore, I can use the closed interval method, and I have to plug in x equal to 0, x equal to 16, x equal to 8 in the objective function. So plugging that in, I get q at 0 equal to 16 to the power 2. Q at 16, I get 16 to the power 2. And q at 8, I get 8 to the power 2 plus 8 to the power 2. And this one is the smallest of the three. So that's the minimum value that I can get, and that would be 128.